let's draw the shear force and bending moment diagram for this beam. So first we'll take a free body diagram of the beam and draw in the reactions. So at the pin we have a vertical reaction and a horizontal reaction. And at the roller we have a vertical reaction. And taking an equilibrium of moments about the roller with our counterclockwise convention, we have a clockwise moment produced by reaction A multiplied by the moment arm, and then a clockwise moment induced by the external load by the moment arm, and that's all equal to 0. And therefore, solving for AY, we obtain 6 on 4 or 1.5 kilonewtons. And an equilibrium of forces in a vertical direction, with upwards being positive, gives AY minus 2 kilonewtons plus our unknown reaction BY is 0. So therefore BY is 0.5 kilonewtons. And we know that AX is 0 by a horizontal equilibrium of forces. And now if we cut the beam, taking a free body of a section that's at some distance x from the pin, we expose the internal shear force and bending moment. So from 0 to 1 meter, if we take an equilibrium of forces with our upwards positive convention, the shear force is equal to the reaction AY, which is constant at 1.5 kilonewtons. And I've taken an equilibrium of moments about the right point of that cut section. With our anti-clockwise convention, we have M minus the reaction AY by the moment arm is 0. So therefore M is positive 1.5x. And now if we cut out another section that's at some distance x from the pin, but this time the cut is after the external force. So on this free body we have 2 kilonewtons acting. The reaction AY, which is 1.5 kilonewtons, and an exposed internal shear force and bending moment. So from 1 meter to 4 meters, taking an equilibrium of forces with our usual positive convention, we have the shear force plus 1.5 kilonewtons minus 2 is 0. So solving this, we get the shear force is minus 0.5 kilonewtons. And I've taken an equilibrium of moments about the right handmost point of that section, with anti-clockwise being positive. We have M minus 1.5x plus 2 kilonewtons by this moment arm here, which is equal to x minus 1 meter, and that's equal to 0. So if you solve for M, we get minus 0.5x plus 2. And now we can draw in our shear force diagram, which is 1.5 kilonewton from 0 to 1 meter, and minus 0.5 kilonewtons thereafter. So as you can see, the jump here is equal in magnitude to the externally applied load. And now if we draw the bending moment diagram, from 0 to 1 meter, we have 1.5x. So 1.5 by 1 is 1.5 kilonewton meters at the point load. And similarly, if we substitute x equals 1 meter here, we get 1.5 kilonewton meters also. So the bending moment diagram is piecewise continuous. And now at x equals 4 meters, the bending moment is 0. And we can see that by these two equations, the bending moment diagram is piecewise linear. So this makes sense because a pin and roller do not resist rotations. Please subscribe, like and comment to help me reach more students.